This video is on terminating and repeating decimals. Terminating and repeating decimals are two types of rational numbers. Rational numbers are a group of numbers, including whole numbers, integers, and most of our decimals and fractions. The key is a rational number is something that can be written as a fraction, which we're going to talk about a little bit today. As long as you can write the number as a fraction, it's considered a rational number. We have two different types of decimals we're going to talk about today, terminating and repeating. Terminating means the decimal ends. It doesn't continue on and on. It stops after a certain period of time. So things like 0.5, which is equal to 1/2. It stops after the 5. You could put some extra zeros at the end, but there aren't any other numbers that are going to show up. Something like 0.125. It stops after that third decimal place, so it terminates, it finishes. You could also have something like 2.75. Any decimal that ends after a certain number of decimal places, it doesn't continue on and on and on, is considered a terminating decimal. A repeating decimal uses something called bar notation. Basically, it puts a little bar over top of whatever part of the decimal is repeating, and that just tells us that that number or those numbers are going to continue repeating over and over again. So for instance, we might have 0.3333333 and on and on and on. So since the 3 is repeating, we'd write it as 0.3 and put a little bar notation over top of it. Maybe we have 0.123, and that pattern of 1, 2, 3, 1, 2, 3 just keeps continuing on and on and on. It repeats. So we would write that as 0.123 and put the bar notation over top of it. Whatever is held inside of that bar notation, that's the part that repeats over and over again. If you look at this example at the bottom of the page, here it was 0.5833333. It was only the 3 that was repeating, so you'll notice that they only put the bar notation over top of the 3. But that little bar over top is what tells us that something is a repeating decimal. Last little piece you might want to circle or highlight in your notes. A rational number can be turned into a decimal by dividing the numerator by the denominator. Basically, you take your fraction and turn it into a division problem, and that's how we turn it into a decimal. So let's take a look at a couple. Here I want to do 1/6. So I take my numerator on the inside and divide by my denominator. As you can imagine, since we're going to get decimals, this is where you're going to have to put in your decimal point and add some extra zeros to allow you to do your dividing. So 6 can't go into 1, so I added my decimal point, and then I can kick in an extra 0. 6 goes into 10 one time. And I work through my division problem. Add a 0 and bring it down. 6 goes into 40 6 times. Get 36. Subtract to get 4. Add a 0 and bring it down. 6 goes into 40 6 times, which is 36. Subtract to get 4. Add a 0, bring it down. 6 goes into 40 6 times. So you start to get the idea that that 6 is going to keep repeating over and over again. So we put the bar notation over the top. Tell us that the 6 is going to be repeating. If you wanted to, you could write your final answer as 0.16 and then put the bar notation over the 6, telling us that the 6 is the part that's going to repeat over and over again. Here, 8/9. So 8 divided by 9. 9 can't go into 8, it goes in 0 times. So we add our decimal and a 0, and lets us keep going. 9 goes into 80 8 times, which is 72. Subtract, I get 8, add a 0, bring it down. 9, forgot to show my borrowing there. 9 goes into 80 8 times, which gives me 72. Subtract, and I get 8. You'll notice already I've got a nice pattern of I'm getting 8 left over each time, so it turns into 80. So you can imagine that that 8 is going to continue on and on. So we know that that 8 is repeating. So we call it 0.8 repeating. Last we'll do 2 11ths. So I want to do 2 divided by 11. 11 goes into 2 0 times. So I have to add my 0 and my decimal point. 11 goes into 20 one time. Subtract, I get 9. Add a 0 and bring it down. 11 goes into 98 times, which is 88. I get a 2, add a 0, bring it down. 11 goes into 20 one time, which is 11. Subtract to get 9, add a 0, bring it down. You might notice that we've seen something like this before. 11 goes into 98 times, gives me 88. Get left with a 2. So you can see I'm going to kind of get that repeating pattern. I'm going to get a 1 and then an 8, a 1 and then an 8. So here, I would write my final answer as 0.18 repeating. The 1 and the 8 are repeating over and over again. So I'm going to put the bar notation over top of it. Once you've picked up the pattern, you know what's repeating, you've worked your way out through the problem, you can stop and use the bar notation if you need to. Now, what do you do if you're going to use a negative fraction? Well, here's the thing. All you're going to do is write the negative sign in front of the fraction, or in front of the decimal after you turn it into a decimal. That's it. Do it exactly like you did the last couple of problems, except put the negative sign back in front when you're all done. So in this example here, they had negative 2/9. So they did 2 divided by 9. Got 0.222 repeating, and then added their negative out in front, because it's the negative version of that number. Down here at the bottom, negative 2 2/3 as a decimal. Well, as you're saying that number to yourself, do you notice how you said negative 2 and 2/3? If you remember back to earlier in the year when we dealt with decimals, that word and is kind of signifying that's where your decimal point is going to go. So you can think of it as it's going to be 2 point something. You turn your decimal or your 2/3 into a decimal, divide it out, and that's going to go along with your 2. So let's see a couple of them here. The first one, negative 1/4. Hopefully we already know that 1/4 is 0.25. So I already knew that one to write it as a decimal. And it was asking for the negative, so I put my negative sign in front of it. That's it. Turn the fraction into a decimal, add the negative sign back on. Next I have negative 5/6. So I'm going to do 5 divided by 6. You can kind of already predict what's going to happen. 6 goes into 5 0 times. So I add my decimal and add on the 0. 6 goes into 58 times. Subtract, I get 2, add a 0 and bring it down. 6 goes into 23 times, which gives me 18. Subtract, I get 2, add a 0 and bring it down. 6 goes into 23 times again, get 18. Subtract, I get 2, add a 0, bring it down. You'll notice I keep getting 20 every time I do it, so 6 goes into 20 3 times. So you'll notice it's the 3 that's repeating in this answer. So I would write it as 0.83 repeating. The bar notation is only going over top of the 3 because that's the part that's repeating in the number. Last one, negative 2 1/6. So you can think of it as two different things. You can think of it as two parts to a problem. First focus on the fraction, then focus on the whole number, and then put the two pieces together. So in this case, it'd be negative 2 and 1/6. So I know my answer is going to have 2 as the whole number. Now let's go ahead and do my division with my 1/6. 6 goes into 1 0 times, so I add my decimal and my 0 to keep going. 6 goes into 10 once, which is 6. Subtract, I get 4, add a 0, bring it down. 6 goes into 40 6 times, which is 36. Subtract, I get 4, add a 0, bring it down. 6 goes into 40 6 times, subtract, I get 4 again. So you can kind of notice that that 6 is going to be repeating. So I take my decimal up top and my whole number down below, and I'm going to put those two pieces together. 2 and 1.6 repeating, because it was a negative 2 1/6. I want to make sure to add on my negative sign. Now, if you have trouble with that idea of kind of doing it as two different pieces, instead of treating it as two parts, let's do the whole thing together. If you remember back from our fraction unit, when you have a mixed number, you can turn it into a improper fraction. Remember, we do 2 times, helps if I draw it in the right spot. 2 times 6 is 12, plus 1 is 13/6. So we just turn it into an improper fraction. Then we go ahead and we divide. Let's see if we get the same answer. So 13 divided by 6. 6 goes into 13. 2 times, which is 12. I get a 1, so I got to add my decimal. So I can add a 0 and bring it down. 6 goes into 10 one time. Gives me 4, add a 0, bring it down. 6 goes into 40 6 times. Subtract, I get 4. So you'll notice we're getting the exact same pattern we did before. That 6 is going to keep repeating. So we really did get 2.16 repeating. Same thing we did down here. Again, with the negative, all you're doing is adding on the negative sign after you're done with the problem. So let's take a look at a couple just to finish up here. 7/9. You can go ahead and divide that one out for yourself. And when you're done, we should see 0.7 repeating. For each one of these, go ahead and try them for yourself. You can pause it and then hit play to have me give you the answer. But all you're doing is doing numerator divided by denominator. If it's a negative, you throw your negative sign back on when you're all done. Some of these are going to be repeating. Some of these are going to be terminating decimals. So -1/33. Go ahead and try that problem and then hit play to see what the answer is going to be. So for this one, we're going to get -0.03 repeating. That 030303 keeps going. For number 3, -2 5/6. Remember, 2 and 5/6. Well, 5/6 is 0.83 repeating. And then because it's negative 2.833333. 10/15 is our next one. Well, 10/15 is really the same thing as 2/3 if we were to simplify our fraction. 2/3 as a decimal is 0.6.